Here, let's look at the present value and the cumulative present value of a annuity, but with flexible periods. So we'll see the effect of the distant cash flows on today's present value. The sneak peek is that the later the cash flow is available, the less present value it has, particularly at a high discount rate, or if that cash flow is available at a very far away point of time. So we'll do two examples. One, we'll do this example, but we'll also extend this to another example based on what we just discussed. So let's just do this example first. So time t, this is an annuity, of course. T equals 0, there's nothing available. So no cash flow at 0. The present value is, let's give it an interest rate of 75% as discussed there. So interest, Alt NU, enter, close, don't format any shapes yet, enter. So 75% equals CF divided by parenthesis 1 plus CE $1 to the power CC $3, just CC3, and then equals this. Now equals this plus 1, 100, Control D, and then equals this plus this. So as we go ahead in time, it adds the cash flows present value with the previous cumulative present value. And all we need to wait now. So let's just show at time t equals 2 equals the cash flow. It's annuity. So this is a 2-period annuity. Its present value will be 89.80. So round it off to 2 decimals, please. 89.80. Round that off as well. And now all we need to do really is to look at it. Let's extend it to 10 periods. 10 period, the present value will be 132.84. Let's extend it to 15 periods now. 16, I apologize, 15 periods, 133.30. So when we go from 3 to 5 periods, the value goes up by $17. Let's see that. This minus that. When we go from 5 to 7, that minus that, the value, present value goes up by only $5. Then we go up from 9 to 7, that minus that, only increases by 1.79. When we go from 13 to 11, only changes by 0.19, and 15 to 13, only changes by 0.06. So if we go sufficiently far in time, we'll see that this thing tapers off to 133.33. In fact, what if we had infinite cash flows of $100? So the formula for perpetuity, it's called a perpetuity, infinite cash flows. So all we need to do is divide this by the discount rate, 133.33. You can see that the cumulative present value and the present value of perpetuity, they converge, but not exactly. Not exactly. So to see that, we can do another small exercise here. So what we can do here is equals this over $CE $1. Okay, and let's just plot these. Let us plot these. So the cumulative present value of annuity, 26-period annuity, and a perpetuity. So at all points in time, we're just plotting it against the perpetuity. Look at that. Okay. So the orange line is perpetuity, and the blue line is that annuity. So this is the 1-period annuity, 2-period annuity. It's 1 period, it's a single cash flow. But you get the point. So as the number of cash flows increase at this discount rate of 75%, they asymptotically, this is called asymptotically. That means when the time becomes sufficiently large, they converge to the same value. And that's a connection between an annuity and a perpetuity. So we can easily find out the present value of constant cash flows of $100 available forever as 133.33. So that's the illustration of this example of a finite period annuity with a huge discount rate and its connection with a perpetuity. Thank you for listening.